Recorded's rolling. It's Thursday, March 5th, SAT day for juniors. So we'll have have Todd here, you guys here. Alright, so alright, so random stuff's going on is guys, what's due by the time you guys come to class Monday? Yeah, AP Classroom Dynamics 1, which is open back in August, so you might have to go back after that. Okay, that FRQ packet we've been working on the last few days, we're gonna post some of the rest of that for tomorrow. Tomorrow. Alright, so guys, I want to do a little bit of physical for you guys, but we're gonna do at least one Atwood, and then I'll give you guys a vote what you want to do after that. It'll be one of these options, but let's do at least one Atwood here. Let's do an Atwood warm up. Okay, so please get Okay, so what if I have 5 kilograms here? And let's put 4 kilograms on the side.
Yeah.
So it's hanging from the ceiling. Okay, so what is the downward acceleration of the 5 kilogram block? What's the downward acceleration of the 5 kilogram block?
Do I remember outlets? Austin, do you remember outlets?
No, but I'm playing like I did it. And I think I do.
How did you? If you do, you just told the whole class you know.
When you get the answer, raise your hand. Oh, what'd you get?
1.11 meters per second.
All right, Justin knows what's going on. Oh yeah, you got that too? All right, nice. Okay. So Justin got 1.11 meters per second squared. Let's see if Justin's right. Gonna find out. So let's go through the whole process here. Because if this is a free response question, they might ask you to draw a free body diagram the whole thing. Oh, if they ask for a free body diagram, are you guys gonna use this tool right here? Yeah, make nice straight lines. Guys, do you ever want to draw a free body diagram? It's like, that force. No. Okay, let's do this. Okay. And what's this weight equal to approximately?
So then we put the
50 newtons. Or if you're using gravity, it's 10 meters per second squared, which you definitely do. Okay. All right, so this one I think would be 40 newtons. Maybe this could be like mass A, mass B, or whatever.
Yeah.
Guys, on each of these blocks, is there another force?
Yeah.
The tension.
It's the same.
And how big is the tension compared to this little force and this big force?
Same.
Huh?
No.
No, okay.
It's all bigger than the small force, but smaller than the.
Yeah, let's go Goldilocks. Go somewhere in the middle. Yeah, not somewhere between 40 and 50.
Yeah.
So I'll call it F sub T, F sub T. Okay. That's just internal to the.
It's the same on both sides.
So to answer this question, you don't actually have to. Oops. You don't actually have to solve it. Okay. Or you could. There's different ways to go about this. Right. So let's go. I usually take you guys through a whole system approach.
No, I want to be.
As opposed to a different way to do this. Okay. So I'll say the acceleration of the entire system, like moving like this, which would also answer this question because of course the large block is going down. Okay. Is whatever what. Or what formula am I drawing from?
Newton's second law.
Yeah, Newton's second law. Newton's second law. It's all about net force on total mass. Like again, if this was a free response question, they'd want to. We'll see. You write that down first before you continue to say, okay, because that looks like a formula from the AP equations. It's this one right here. Is this one right here? So got that. And yeah, using this whole system approach, what would the net force be on the two blocks? What? Yeah, 10 newtons because it's 50 newtons minus 40 newtons. Right? See, these two are playing tug of war. One guy says let's go clockwise, the other guy says let's go counterclockwise. Okay? Anyways, how much total mass is being moved around? 9 kilograms. It's 5 kilograms plus 4 kilograms. Okay. Remember, guys, forces are vectors, so they can add or subtract from each other depending on direction. Okay. But mass, inertia, that's like a scalar value, so it's always just going to add. Okay.
That's like 10.
So I have 10 Newton net force acting on 9 kilograms mass.
Plug it back in.
1.11 meters per second squared. Oh yeah. Justin got it right. How about that?
Yeah, I like multiple. Yeah.
Yes, would a good follow-up question be what could be a good follow-up question to this?
Distance it moves.
Okay, yeah.
Can I-
Distance it moves as a function of time. Right? You could say how fast moving is a function of time. You could say how fast as a function of some distance. Actually, speaking of this last one, how fast is a function of distance? There's a completely different process you could use that's not even any of this that we wrote down. Because what's a different process that can answer how fast a function of distance? Conservation of energy, right? Which is a different setup, but it would get you the right answer. Okay. Another good follow-up question would be what's the tension of the string? And for that, I would either focus on this block or this block instead of using second law of motion as applies to any single block. Okay, so all right. So guys, for the rest of this class period, because we got one class, so you got to do one or the other. Okay. I can either give you guys time to do your AP classroom assignment, or I got board games back there, books. I'm going to get opportunity, or if you have something else you have to work on. Okay. Or we can spend the rest of the day, class period. We can do more notes, just like we just did here. Okay. So let's do. We're just going to do majority vote here. So who wants to do option A? Option A. Got 1, 2, 3, 4, 5, 6, 7. How about option B? All right, 7-0. 7-0. 7 this. That's a wrap on this recording.